Well, it says pause back here, so I think we're good. Guys, hold on. Is it embedding my web camera? I think. Oh, wait. Hi, everybody. Let's get to work. So my husband's here to help. Say hi.
Hi.
I don't know if you're in the picture or not. I think it would be here. You are. All right. I told you guys he's a smart cookie. Wait till you see what I'm going to make him do. So it should be recording this application window. If I did my job right. Should I stop it and test it? No, I can do this without it. All right. So I'm going to take this away. Let's say that we have a collision. You ready? Mm-hmm. So this ball weighs more. Sorry, it's really dirty. It's the dog's. And
it's a treat ball.
And
put
you
treats in it.
And you come
this
and
is from Chuck E. Cheese.
Yes.
Spiky.
And you boom, and they do that. Okay, so they collide.
Is that a collision?
That was a collision.
Wow.
Two things. Yeah. So we have two objects. That was a good example. We're going to talk about. That's all I needed this for. Yeah.
Oh.
We're going to talk about this thing called an elastic collision.
Mm-hmm.
What's an elastic collision? Don't say something because you'll.
Then why would you ask me a question?
I know. I will. I'm talking to my kids.
This is rhetorical.
They should be saying elastic collisions is when the kinetic energy in the beginning of the problem before the collision is the same as the kinetic energy after the collision of the two objects together, whether they're both moving in the same direction or in opposite directions or one still, that the kinetic energy is equal.
Or they're just saying, I'm going to wait for her to tell me the answer and not really think about
No, they know that. You guys know that. I really hope that we're being recorded. Okay. So, number one.
That's not, how's that number one?
Number one, I'm talking about elastic collisions only, where kinetic energy is conserved. There's a neat formula we're going to derive.
Is that the technical word, or do you think it's a neat formula?
No, I don't know. Okay, so we have to have two objects in a collision. They can both be moving. One can be at rest, one moves. They can be moving towards each other. Doesn't matter.
Do you feel the need to make that noise every time you?
Yes, and kids, whenever we cancel stuff out, we go.
Mm-hmm.
Okay, so
formula. I've had too much food.
Formula number one is initial momentum always equals final momentum. Final momentum is always conserved, whether it's elastic or not, whether our kinetic energy or stays. Momentum is always conserved. So this is your momentum equation.
But why is momentum with a P?
Momentum. I don't know. Did I spell momentum right? Mm-hmm. This is your conservation of momentum equation. So momentum before has to equal momentum after. Now watch this. Because it's elastic, so this is for elastic only.
It's a little light. Yeah.
No, it says elastic only. I said it. I said it out loud.
I know. I'm trying to read it.
Okay. Elastic only, there's the kinetic energy formula. So you can say that the kinetic energy at the beginning is equal to the kinetic energy at the end. You're right. That light is bad. I turned it off.
Try to tell you.
Should I turn there?
Ooh.
Is that better?
Mm-hmm.
So what you're going to learn is we're going to find that the velocity of the first one initial.
Ooh.
The initial velocity of the first one plus the final velocity of the first one. So how fast this, is going to equal the sum of the initial velocity of the second plus the final velocity of the second.
Is that because energy is conserved?
Yes. But what we're going to do is this, you can't just make up formulas. So we're going to prove this formula so they can use it on their test. This is a new formula that wasn't in their notes, and it's going to be really helpful.
But I'm guessing it's a new formula that was discovered years ago, and that person's no longer walking.
Yeah, there's quite a few people who proved it on YouTube, and I'm just stealing their steps.
Or was it also proven
Well, I mean, math is math.
Math is math.
So you can do this using substitution and linear combination and squaring binomials and being really super miserable.
Do what? Math or being married? You said you can do this. You're talking about...
Okay. So momentum, ready, Nate? Momentum is mass times velocity. But if we have two objects, we have to add mass and velocity. So the way we initial this is mass 1 plus velocity plus initial velocity of the first one, plus mass 2, initial velocity of the second, equals mass 1, final velocity of the first, plus mass 2, final velocity of the second. That's conservation of momentum. That is a key, super duper important formula for them. Did you hear that, guys?
Mm-hmm.
But if it's elastic, kinetic energy is 1/2 mv squared. Well, that would be mass 1, velocity 1, initial squared, plus 1/2 mass 2, initial velocity of the second squared. Am I losing you? Because kinetic energy is 1/2 mv squared.
Well, you lost me when you wrote that your halves differently with the vertical,
sorry guys,
with the horizontal versus the
confusing.
diagonal.
Equals 1/2 of the mass 1 of the final velocities. Sorry, of the final first velocity. So the final velocity of the first one.
Is that
plus
squared?
1/2. Thank you. 1/2 the second mass times the velocity of the final second. Like okay. In other words, guys, the initial momentums added together equal the final momentums added together. The initial kinetic energies added together equal the final kinetic energies added together. I have chili in my fingernail. Okay. Okay, ready for this? Okay, good.
Should I say yes in case I can't see our faces?
No. Hold on one sec. Hi, guys, we're back. I had to pause to make sure I didn't do anything stupid. Okay, what do you notice about everything I'm pointing at? They all have.
Did you point at the halves?
I did.
Is that what you pointed
They
at?
all have a 1/2.
Okay.
So
yeah.
In math, you can cancel anything that's the same throughout.
And they go.
That's right. We do that when they zero out. These don't technically zero out. They technically divide out, multiply, whatever. Okay. So what we're going to do now is rewrite what we have. So we have m1v1i squared plus m2v2i squared equals m1v1f squared plus m2v2f squared. So we just got rid of the halves. Now what we're going to do is get everything that has an m1 on the left and everything that has an M2 on the right. So
why?
Because
why can't you put the M2s on the left and the M1s?
We could, but
right?
I don't want because just
okay.
So this has an M1. What else has an M1? Good. So to move this whole thing to the other side, we would.
Wait, what are we doing? So no, I'm looking at it. This is a positive, so we got to subtract
yes.
it. Yeah.
So this would be m1v1i squared minus m1v1f squared equals, so this stays, m2v2f squared minus
I'm with you.
I'm
with you, dog.
Girl.
Sheep.
m2v2i squared. Now,
terrific.
What's common? What's the GCF on this side?
What's GCF stand for?
Greatest common factor. What's in both of these terms?
Well, let's see. You have an M1.
Good. Stop there. We're going to take a GCF out of M1. So we're going to have V1I squared minus V1F squared equals, guess what we're going to factor out of the other side?
I'm going to go with M2, Alex.
M2, good. V2F squared minus V2I squared. Now, when you learn how to factor, do you remember difference of perfect squares back from 9th grade?
I'm going to say it deals with something like with pluses and minuses.
Yes.
Is that?
Yes. Like if you have x squared minus 4.
Hold on.
Factored would be.
Oh boy. Would that x plus 2, x minus 2?
Yes, it would be. Because you took the square roots of each, one was a plus 1. We're going to do the same thing. So we're going to have this M1 chilling. And then this is going to break apart to V1I plus V1F and V1I minus V1. Oopsie.
So far, I haven't gotten lost.
Good. Equals M2. Do you want to try to do this side?
Let's see here. So that would be what? V2F plus V2I. And V2F minus V2I.
Honey, you're so smart.
That's why you married me.
That's why you married me. All right. Now I need to pause and think. The music in the background is very distracting for me. Hold on. I know we can do something really cool here.
Really cool, or just in your
Give me a
world
second
cool?
Because I'm pretty sure I know. But
here.
No, you're going to do great. Are you ready? We got this. All right. I want you to, on the momentum equation. So guys, just pause on the kinetic formula, the kinetic energy conservation
You
equation.
put Molly's pause on it.
Pause. Okay. Get this M1 to the other side. Get that M2 to the other side. Go ahead.
You're talking to me?
Yeah.
What?
So start with this.
What am I doing?
See M1.
M1 B1I.
Okay, now pull this one over.
Minus M1 V1F.
Equals, keep that there.
M2 V2F.
Take that over.
Minus M2 V2I.
Okay. Now, what's the GCF on this side? Just like over
here.
What would we have left?
Well, V1I minus V1F.
What would we have on this side?
M2 V2F minus V2I.
Okay. Now, look here. Okay? So guys, this is an important step right here. Okay, ready? Do you see
You're not supposed to use pen in math.
Do you see how you can when you're smart enough? Do you see how this is the exact same as where? Over here. Here. And here. So you guys see my two blue underlines? Because you guys know I could have rewrote these like this. Like these two were flip-flopped. I could have put the minus sign in this one and the plus sign in this one. It doesn't matter. Multiplication is commutative? Associative? Who cares? You can multiply in any order.
Who cares? How
I
dare you
don't,
say that?
because I just need them to know you can multiply in any order. Hold on, that's super crooked now. Oh boy.
What are you doing?
Oh gosh. I feel like I need to blame you. Okay. Okay, ready? Now you're probably out of the picture. All right, sorry guys. So what we're gonna do is you see these. Do you see these two blue underlines? We're going to
see them.
Pick them up and throw them away and replace it with this stuff here where my stars are. This is the transitive property. Like if these things equal each other and this one equals that one, then this one can replace those ones. Was that too much? Did that make sense?
Yeah. If you have 3 equals 3 and that's 3, you can just put 3.
Yeah, transitive property. Okay. So we are going to take away this M1. Take away that.
I didn't make it 0, you said.
I know. Okay, and we're going to replace it with that. So I'm going to do M2 instead, because I'm replacing, because it says up here that it's equal. M2 times V2F minus V2I. Oh, but we still have that little guy. He didn't go away. Right. So I'll put him here. V1I plus V1F equals,
boy.
Why did I do that? Oh, I got to get really close so I can write it. Sorry, guys. It equals this stuff.
Oh, I don't have my coffee.
And we're almost done, okay?
Coffee. Let's talk about coffee a little bit. Oh, you're busy with your physics. Okay, you're
ready?
back. You're back.
I'm back. I just had a really small write this line down on the next one. Now, are we ready for some stinking magic? What's the same?
It's all math.
It's all multiplication. It's the same thing. It's all multiplication, which means like if you have something on the left, it could cancel with something on the right. So, what? Oh, what matches?
Let's see. Well, this matches that.
Yeah.
Why aren't you writing in pen anymore? You're not confident.
Can you keep going? What else matches? We're literally done after this step.
The M2 thingy?
Yes. Isn't that beautiful?
So that's it. That's
so
the
our
answer?
final answer is what? So this is the special formula that I did not see on Mr. McBurney's notes, because you guys remember, like, they had to memorize their formula. So he probably just thought, like, why teach them another formula they have to memorize? But like this one, you guys can write down because I'm going to let you use it.
So are you throwing him under the bus saying he did a bad job? I know.
Oh my gosh, no!
Is that what she's trying to say?
No, he was so. I'm sorry you don't have Mr. McBurney. I know he's better than me, even though he is like my tiny little brother, younger than me.
What?
His IQ is at least double mine. Okay, go.
So V1I
Yes.
plus V1F
Yes.
equals
Yes.
V2F
Boop, boop.
plus V2I.
Which, if we wanted to rearrange that, we could just do V2I plus V2F. If we wanted to have like initial plus final.
So if you're a little OCD about it.
Yeah, because like, usually I like initials and then finals. But what we just did, guys, is I told you this is what we were going to find. And guess what?
So
we totally found that. I just can't let it go.
So let me get this straight. This was the answer. You just made them prove that it's the answer?
Yeah, like this is a formula I could have just given them, but what fun would that be if they didn't?
Did you guys really have fun?
I didn't believe. I saw somebody using that formula, and I was like,
them.
cheaters!
Let's ask them if they had fun. Did you have fun? Show of hands. Anybody? We'll go back to these.
I miss you.